So I'm going to present information associated with the 1000 battery monitor system. I have it identified as XX1000 because depending on whether you want a panel or a portable unit or a rack-mounted unit, different designation in the front. So what this does is our battery monitor system. It is monitors battery system voltage. It's monitoring the battery string, not individual cell voltages. It provides for monitoring the impedance of the system, open cell detection via monitoring of ripple voltage, ripple current, and depending on what's happening with your impedance, is going to be an indicator to go back and check your battery systems. If you go back and check your battery systems and everything's fine with the battery system, then the next thing we'll do is lead you to go check the AC filter caps because they're probably degrading. Recently had a utility where they found out that that was the exact issue. Positive negative ground fault detection, and this loose open strap detection, battery terminal corrosion, high impedance is associated with monitoring of impedance. All right, where'd my little arrow go? That's a good question. Where's the name? Oh, there it is. Okay. All right, so this is a 25-1000. The 25 means panel mounted. And you can see from the indication, so this is monitoring, this is a parameter of the end result. This is the parameter on the bottom window. It says battery, and that's 125 volt DC system. And one of the things I didn't say in the last presentation was on each of the cans, we actually have that indication of all the contacting associated with it. It's actually a nice thing to see right off the bat. And that's our portable unit. This is the panel mount in a portable unit. It can go from substation to substation. What's nice about this, it actually has LEDs for all the various alarm functions. And this is your DMP connection RS-45 input. This is tie into the battery positive and negative side. You put an exterior ground on this in case this is for using a handheld detector to find grounds on the system. And for impedance monitoring, you have a current sensor that you tie into the battery monitor. And then if you have I-420, this is your connection for I-420. So this unit, the panel mount, rack mounted, or portable unit, as the standard battery monitor, comes with DMP, Modbus, or I-420, which is a step above our last versions of battery monitors. This is a rack-mounted version, and this is showing a dual battery voltage system, but it can be single or dual battery voltage. And this is showing you as for you. Once again, you have your LEDs showing positive, negative ground fault, high, low battery voltage, open battery, and AC power loss. This is the portable unit showing you, once again, you have the LEDs for all the various alarms. You have the RS-45 connection. This is a common when you're hooking up external connections for the LEDs. And exterior ground, this is the current sensor, limit, reset, and alarm buttons. Alarm LED, this is LED for the alarm. It would come on here, and then it'll come on your LED showing you which alarm is actually operating. The reset button is when you have it where you might have an alarm that's latched in, and that's one of the features. You can latch them in or not latch them in. And this limit button is designed to allow you to, from the front of the panel, set your battery volt, all your alarm features and all your system features that you're going to use. This up on the upper left is a handheld detector that is a $230 component that can be used to find the ground in case you have an actual ground occurring on the DC bus system. What we have is a pulsar. There's a little pulsar, and I think further down on another presentation there, you'll see that the pulsar's on. So that's sending out a little ripple current across the battery DC system. And if you have a ground, you take that handheld detector, turn it on, and that will help you locate the ground. And then you would go through isolation process if it's a bundle cable to find out which cable that would be. So this is a 15-1000, so that's a rack-mounted unit. So this is a 4U system, and the 16-1000 is another unit that we sell, is a 3U unit. What did it go backwards on me? Maybe I hit it backwards. So this is the indications you're going to have. We'll just go right through it. So standard condition, you're at 125 volts. This is your battery. You're monitoring the battery. And if I push my little scan button, which is right here in the center on the bottom, underneath the feature that you're monitoring, then I'll switch to the next positive DC bus, then the negative DC bus, which is half the voltage. If you had a ground, it would show you a ground. In this case, it's not, you don't have any ground, so it would be a positive ground or a negative ground. That would indicate. And I could actually hold that scan button down, and it can be automatic scanning or just individual pushes to switch between the thing. If I hold it down for like 4 seconds, it goes into an automatic phase, which is kind of a nice thing. I could walk into a substation that's a panel mounted unit, and I see quickly what the status of my battery is. This gets into when you're monitoring the ripple voltage. So you can see it's 575 millivolts. Your ripple current is 3 milliamps. And time delay, I can go from 5 seconds to 60 seconds. And when for your chargers, you can have a single or a 3-phase. And you have to make sure that you identify what your charger is doing. If you have a single-phase charger and I put it on 3-phase, then I'm going to be reading 3 times the ripple voltage, ripple current, so I'm going to get an alarm immediately. So that's important to make sure it's properly set. The battery monitor alarm, so again, high-low voltage, positive, negative ground, high impedance fault. The high impedance fault is going to be indicative of corrosion. You could have degradation of your cells or an open strap, a loose strap. If you have ripple voltage, ripple current, you know, that's going to be as your impedance increases. That means your ripple voltage is going to go up, your current's going to go up a little bit because, or your current would be going down as the battery ages. Okay, once you get, you know, if you have a step change, you go above 200 millivolts and less than 10 milliamps, that means you got a problem with your battery. So you go check your battery. It could be corrosion. It could be a loose strap. And if the current went down to 0, you have an open cell. If you go check your battery and it has none of those, then you go to the AC filter caps, okay? Because you're probably degrading there. Loss of AC voltage, so that's an important aspect. A lot of non-utility type locations may have no loss of AC. You know, like a wastewater facility I walked into, and they had lost AC charges, went 3 months, and then they had an outage, and they had no control of their breakers and system protection devices. So that was a real issue, besides the fact that they lost the battery. So they had to get a new AC charger, they had to get a new battery, and they had lost control. This last gas process I'll talk about later on. This is basically, well, actually I can talk about it now. So you have a high-low voltage. So a lot of times if you have a 125-volt DC system, we'll say your high voltage is set at 142 volts, your low voltage is typically set at 105. Some people, what they do is instead of setting the low voltage at 105 volts, they would set that at 120 volts, and then 105 volts would be your last gas. So we're looking at adding that feature. So our low voltage would be 120 volts instead of 105 volts. And 105 volts would be my last gas, which means get your butt out there, take care of your system because you're about to lose your battery and you're not going to have any control.
When they're coming, is that an update that if they bought one today, they could
It's not available. We have to test it.
Okay.
Okay. So I would say maybe within a month we may have that.
Okay.
So setting alarm step points. So we have this limit button on the right here. So I'd be sitting there monitoring my battery. I hold the limit button down for 4 seconds. You see my limit, LMIT, would come on. So now I'm ready to toggle up and down on the left here for setting my alarm limit. So first one would be high battery voltage. I hit the limit button again after I've gotten to LMIT. My high battery voltage comes up. And it's set 142 for a standard 125 volt DC system. That's what we set it at the factory. And you use the up and down arrow to the left of that HVAC. I hit the limit button again. Then I go to my low voltage. And it doesn't show my low voltage, but that's what it says. It'll be LBAT. And then I use my up and down arrow. And the low voltage is typically set at 105 volts DC. I have my positive ground and negative ground. and then I set that at 13 volts. That's what it comes out from the factory. And if you have a location that has high spurious background noise, that can be changed using up and down arrows, but there's a calculation to come up with to find out what they should be setting at. And that the utility would set at, or you guys may, be the one guy determining what the voltage should be set at. Ripple voltage, 200 millivolts. That's what we know to set it at. If it goes above 200 millivolts, it's an alarm issue. If it goes less than 10 milliamps, the ripple current becomes an alarm issue. Time delay, I say 1 to 60 seconds here, but it's really 5 to 60 seconds. So you put the time delay and you use up and down arrows, set the time delay. And that's to preclude spurious operation. If you get a momentary alarm, a spike or something, and that precludes that. AC monitoring, single or three-phase. Ground detection, pulsar on and off. You can see here, the pulsar light is on. So if you're not going to be using the pulsar, you can turn it off. Some people won't buy the pulsar right off the bat, so you don't want the feature on and just turn it off. But it's always available. So all these features are always available. It's just people turning them on or off. Internal buzzer off. This is a buzzer that's internal to the meter itself. Very shrill sonic alarm that's obnoxious. So most of the time I have it off. Latch on or off. That's if you want to latch in, an alarm occurs, and then you want to know what the alarm was. Then it stays there until you go back and you hit the reset button in the middle here, and that would turn off the alarm. Next one would be sys. Now, when I get to sys, SYS, I hold the limit stop button down again. Now I can set the features that I want to use on this battery monitor. So we have AC. Do you want to monitor AC? Yes or no? Well, my portable unit that I have here, I have to provide another power supply providing AC to this. So I have no right now, so I don't have a loss of AC feature. Ripple voltage. If you're going to be monitoring impedance, ripple voltage, ripple current, and high impedance would have to all be yes. And then if you're using DNP or Modbus, you want to be able to put your address and then whatever baud rate. So, as I said at the beginning, this unit is not for PRC05-2 compliant because we don't monitor individual cell voltages. We monitor the battery strength. So, PRC05-2 says you got to monitor individual cell volts, you got to have temperature monitoring, and 24/7 output. Okay, we would get 24/7 output by tying it into a data storage system, but we don't have a data storage system associated with ours. Now, when it ties into your battery monitoring system, you bring individual cell voltage, your temperature monitoring, and all the data storage. So now, with impedance monitoring and the ground detection, you have a complete system that's addressing PRC05-2. This just shows you basically a standard schematic showing the size of the can, what you see in the back of the meter. Get a better view of the next. This is showing you all the alarm relays, and the next schematic here is showing you all the terminal connections that are on the back and their functions. Okay, so we have output alarms K1 through K4 relays. So let me go back here. Yeah, K1 is my ground fault. K2 is positive ground fault, negative ground fault. K3 would be my high battery voltage. Now K4 is my low battery voltage, open battery, lost space heated charger. And so K1s and K3 are always normally open contact. K4 is normally closed when you get the battery monitor. When you energize the system, that normally closed contact opens up. So all your alarm functioning is taking place by a closing of the contact. Okay. Some people get confused on that K4, understanding, so, well, it's set up, normally closed, energize it, and you got a better explanation, Wayne. What do you call that? Fail-safe. Fail-safe. Okay. Okay, where'd it go? This is our old meters. They had all the posts. It was a real pain in the rear. Now this is a new meter, the back of the meter. And this J1 function here, this is a connector. That's where when you put it in the panel, in the rack mounted or the portable unit, this is where your output to the LEDs comes from. So if you had a panel mount, which is, would be nice to have, is you could actually tie in separate LEDs. If somebody had a panel they wanted to add the LEDs, they just tie the J1 output using that. So once again, it's just showing you which normally open, normally closed contacts. All your K1s are Form C, and then you can see where 4 to 20 milliamp outputs, 4 to 20 milliamp returns. This is the positive and negative for your current sensor. So it's actually fairly clear as far as how to hook this up, because we were asking, well, is there any technical support needed? It's pretty simple, I think once somebody's done it once, you're never going to forget. Now, if something doesn't work, that's a separate technical issue, okay? And that would be, if you go to Boston, we get into discussion on Leon now. This is how you hook up the portable battery monitor in a substation. So this is really simple. There's a common right here. That's, you hook it up to ground, because if you actually have a ground in the DC bus, now I have a path to be able to send out that pulsar across to help find the ground. Other than that, this is my positive side hooking up between the AC charger and the battery bank, and my negative side hooking up to the negative bus between the AC charger and the battery bank. That's as simple as it gets. And then the only other thing we have to do is if you're going to be monitoring the impedance, I'll get to that in a second. This is just an explanation how the open cell detector works based on impedance monitoring. If you're monitoring your impedance, your ripple voltage goes above 200 millivolts and your current goes to 0, you have an open cell. So it basically explains that for you. And this is impedance monitoring associated with loose strap corrosion taking place at the terminals. And as I said before, if you go, and that's making use of a current sensor that's monitoring that ripple current that the AC charge puts out a ripple voltage, ripple current. So in some cases, there are AC chargers that put out pure DC effectively, so you're not going to have ripple voltage, ripple current. So we sell a little separate system that will put out that ripple voltage, ripple current, so you can monitor the impedance. Faulty AC charger filter caps. You go and check your battery because you have the alarm, the high impedance alarm. You go check your battery, there's no corrosion, no open cell, no loose strap. Sends you the AC filter caps and you find out that your AC capacitors have an issue. And typically that's what we just had a utility down in the south that went and did this, and that's exactly what was wrong, so they replaced the filter caps. And they usually last, 7 to 10 years. I mean, you guys would know that better than me. Anyway, I'm preaching to the choir. The ground fault theory of operation, it basically shows how it's set up. And then if you have a substation that has high spurious noise, background noise, a lot of times that will throw things off, and you want to set your ground fault higher than 13 volts. It will help you come up with a new voltage setting. There's a little calculation that I may have included, maybe not. If I haven't, I'll get it to you. This is a current clamp-on sensor. I think people saw it before that were in the left. Okay, so it's a current sensor. I clamp it on one side of the battery, the cable in either the positive side or negative side. And this ties into the battery monitor where I showed you the little plug for positive and negative side. Now you have your impedance monitoring. Very simple. It's a split core current sensor, so very easy to attach. And we haven't found any cables that are bigger than that, so I think we're good to go. So you can see here, this is a ripple current being monitored on one side, output to the battery monitor. Tools available for customers. You can give them the battery manual, which we're up to Rev F, and it's actually a pretty detailed information. It's actually fairly well laid out. And then you have the quick start guide, and that's for everybody that doesn't like to read the manuals, that you can use the quick start guide. And actually, that's pretty clear too. And I'd asked, Diane, right? Is that right? Correct? Syed, to review that, because we've gone through a process. When we developed the manual, we actually developed a flow chart of how everything works, and it was nice, but we kind of modified that. We had engineering development, we had to make it in English, you know, so then we went back and created a quick start guide that met our standards. So, you know, if we understand it, it should be fairly easy for the customers to understand that. And then, so then you have the DMP profile. If they're going to use DMP or Modbus, not I-420, this will help them as far as setting up the DMP points through an RS-45 interface. So, we used to, on our old meters, 25-469, you could have standard features, high, low voltage, ground fault detection with hardwired outputs. You could have options of I-420 or I-01, or you could get another one with digital, the DMP 3.0 or Modbus. 25-498 came with the loss of AC charger, open cell detection, you know, and the filter cap issue. And you can have analog I-420, I-01, or digital output. So a lot of times these were different monitors. So this is why these are going away, because the 25-1000 or the 15-1000 or the 50-1000 are rack-mounted portable and panel mount. They have all the previous features, but then they add the high impedance corrosion detection, the pulsar, and the DMP 3.0 or Modbus I-420 in one meter. So now it's just whatever features people want to use, whatever DMP or Modbus I-420, they can use that. So a lot, you know, so if somebody wants to buy a 25-469, we tell them you might want to consider buying a 25-1000. 25-469 is going to go away in probably 2 years, and the features you're getting out of this supersede what you had before. And I think typically we found that they transfer right over. Shows you the pricing that we gave to SBS. I think last time you talked about.
So if you go back one slide, the application engineering team creates a bill of material, they need to verify that it's the right product, or produce quotes. So they're in touch every single customer, every single product that goes on the cart. So can you just kind of walk through those different part numbers so that it's clear what they should be ordering and putting on their quote when?
All right, so we have 24 volt, 125 volt, and 48 volt DC systems, okay? And actually, this identifies all the leads. So when you're looking at this, the 19-inch rack mounted is 4U, okay? So it's all 1000, but it's designated by 15. Okay, 15 is the rack mounted 4U system. So you can see 15-1000-125A-1, 48A-1, 24A-1, 250A-1. So these are all the ones with DMP, Modbus, I-420, okay? And it's 3 weeks. When you go to 24A-1, 250A-1, those are not the typical ones that people would order, so the lead time goes out to 4 weeks, okay? Most of the time, you're going to come across the 48 and 125 volt DC systems. So the 4U, okay, this is a 4-wire. This would be 2 batteries, you know, a double battery system. So that's going to be the 15-125, 1000-125A-2. So this is a double battery monitor system. So once again, it's still the 3-week lead time and a 4-week for the 24 and 250. And then you get the 25-1000. This is the panel mounted, just the meter itself. DMP, Modbus, I-420, and once again, 3 weeks and 4 weeks. The handheld ground detector, so we give it a 3-week lead time. That's a handheld detector that you turn on and you use a pulsar, helps you find the ground. The high impedance current sensor gives you the part number, and it's 3 weeks. It gives you the price. And then the portable is the 50-1000, and actually, on the portable units, and I didn't see this, it's a 6-week lead time. I'll find out if that's going to be, yeah, you'll be stocking that. So once again, 48, 125. In this case, they're all 6-week lead times, okay? if you come across somebody that has a need for an I01, then that's a different battery monitor. And
No, well, actually, we're probably only stocking 48 and 125 ever, unless there's a specific customer demand.
and then you would probably stock an I420 DMP Modbus, that version.
Right.
Yeah. But that,
We're utilizing the exact same part numbers and the exact same descriptions. So when we order it or when we sell it, it's the exact same part number.
So the key thing when you're sending out your quotes, I would, you have the part number and also have the schematics.
Yep.
Okay.
We'll put together a package with walls, description, catalog, page, quick start guide, that way.
Yeah.
Full process, all of that.
And these are all the accessories, the battery monitors and accessories. So once again, the description, the part numbers, and then down at the bottom, you can see the handheld, the ground fault handheld detector, the 25-1100-GF, the high impedance current sensor. Okay, and then we also down here, and I didn't see a price that was given to you for this, the 25-1100-H2. That's okay. It could be, but that's where if the AC charge is just put out straight DC, you need something for, if they're going to monitor impedance, you need something that's going to develop the ripple voltage, ripple current. Okay. So that's basically the presentation. Now we get into who do you see? Questions and answers. And you guys that are in the field, feel free to ask questions as we're going along here. So we focus on facilities managers, safety managers, the battery maintenance staff, electrical engineers, electrical contractors, and actually consultants too. So, because you want to make sure the consultants are aware of what you have available for them when they're speccing in stuff. Second question, why would you want to use a separate battery monitor, recognizing that many battery chargers have monitoring features? So, the first reason I always use when I talk to people is that when I go to BatCon, and I've been several times, and we go every year, the battery experts say, if you want to monitor your battery, monitor your battery. AC charger is an AC charger, monitor your battery, okay? Your AC chargers may have some monitoring features. A lot of times, you don't have independent outputs identifying what the alarm is, so you have to go out and send somebody out into the field to find out, hey, do I have a ground? Do I have a high-low voltage? Do I have a loss of AC? So, and in some cases, that's the distance, takes time. And if you have a ground, and you knew you had a ground, you're not going to send a guy out to find the ground. If you have a low voltage, you're going to send somebody out to find out what's going on, because that's an important thing. So, and that's pretty much what I say to the people when I go see them. And you guys would probably have a lot more to say than I would on this, based on your technical experience. So, our battery monitor, as I identified at the beginning, monitors the battery string, not ICV. Okay. We also don't monitor temperatures and don't have output collection of information. Whereas tying it into your system, now we have the ICV battery monitoring, the data sourcing, and temperature monitoring. So that meets all the PRC 05-2 requirements. Our battery monitor by itself does not. Okay. So if you have somebody that's out there that doesn't care about PRC 05-2, which is all your bulk power substations, our meter is good to go, and probably one of the most cost-effective solutions out there. Yeah.